For this video, I'd like to talk a little bit about how to do the problems with the normal distribution. Adults' men's heights are normally distributed with mean 70 inches and standard deviation 2.5 inches. What is the probability that a randomly selected man will have a height between 67 and 71 inches? To get started with this problem, the first thing that we need to do is basically to convert to standard units. So suppose I let x be the random variable in question. So I need to find the probability that 67 is less than or equal to x, which is less than or equal to 71. Now, as discussed in class, we can replace the x with a standard normal random variable in the following way. We have 67 less than or equal to 70 plus 2.5z, where z is a standard normal random variable, which is then less than or equal to 71. And then I can isolate the z in the middle. And to isolate the z, I need to take 67 minus 70 divided by 2.5. And then on this side, 71 minus 70 divided by 2.5. So that gives me the chance that z is between. Okay, on this side we have 1 divided by 2.5, which is equal to 0.4. And on this side we have negative 3 divided by 2.5, which is negative 1.2. Okay, so in essence we now need to find the area under the normal curve. So what we've done is we have a bell curve. The mean is at 70. The size of the standard deviation is 2.5, so I'll put 72.5 over here and 67.5 over here. So those are the values in terms of x. And what I have done is to change the units from, instead of inches, to standard units. So that's 0 in standard units, that's 1 in standard units, and that's negative 1 in standard units. So that 67 is about here, and that corresponds to a value in standard units, which we found to be negative 1.2. And 71 would be about here, and that corresponds to a certain number in standard units, which is about 0.4. And so the essence of the question is to figure out the area under the curve between these two lines. Now, ordinarily, the way that we would compute the area under a curve is by integration. Unfortunately, the integral of the PDF is actually very hard to get. In fact, it's impossible to get analytically. So, but the good news is that there are numerical techniques that can be done, and most technology packages that are available can do these packages. So in this video, I'm going to talk about 3 of these ways that this can be done. The first way is simply with a table. So let me pull the table up. So the table that you see in the book, or what's simulated on the screen here, we have 0.40. And so the number that appears right here, 0.65542, that corresponds to the area to the left of 0.4. So the area to the left of 0.4 in Z, all of this to the left, including the white area that you see over here, would be the number that we saw on the table. And let me pull that back up again. That was 0.65542. So let me write that down. Okay. Now that's too much, of course, because the area to the left of 0.4, the area to the left of this line here, includes a shaded area, but also includes the area here to the right. in white. So I need to subtract off the area in white, and that would be the area to the left of negative 1.2. So for that, I go to the table again, and this time I look up negative 1.20. And so the area to the left of negative 1.20 is 0.11507. 0.11507. And then it's just a matter of subtracting to get the area here. This would be, just doing this in my head real quick, we have 0.54035. And so the chance of finding a randomly selected man with a height between 67 and 71 inches, assuming that they're normally distributed, would be about 54%. Okay, so that's using the table. The advantage of the table is that it doesn't require any special technology. The disadvantage of the table is that it only gives the areas for the x-coordinates to 2 decimal places. By that I mean, here I have negative, if I wanted the area to the left of negative 0.94, the area to the left of negative 0.94 would be this number right here. Getting the area to the left of negative 0.946, however, would require a little bit more work because of that third decimal place. So the advantage of the table is that it doesn't require any special technology or any great expense. The disadvantage is that you only have the numbers here to 2 decimal places, and if you had something to 3 or 4 decimal places, that would require interpolation. The second way of doing the problem would be to use Microsoft Excel, which I'd like to demonstrate here. So if I want the area to the left of negative 0.4, I would type in equals norm s dist of 0.4. And that would be the area to the left of 0.4, and that, not surprisingly, matches what we found on the table. Also, we could type in norm dot s dot dist 0.4 true. That is a second command that would work in Microsoft Excel 2010. This does not work in Excel 2007. The previous command does work in Excel 2010 and 2007. This command here with the dots in it only works in Excel 2010. And you have to include the word true to mean that I want the cumulative area, not just the y-coordinate. And that returns the same thing. Okay, in my case, I wanted the area to the left of 0.4 minus the area to the left of negative 1.2. And this should evoke the idea of integration. When we integrate between negative 1.2 and 0.4, we get the indefinite integral. Then we plug in 0.4, we plug in negative 1.2, and we subtract. And so this basically does the integration for us, and then all we have to do is plug in the endpoints. And so not surprisingly, we get the same answer that we had before, 0.54035, and obviously I can get that to as many decimal places as I want. The table only gives us the answer to 5 decimal places. The third way of doing the problem would be to use a calculator. And so let me show you how to do that. So the command on a TI-83 Plus would be distribution. I go to normal CDF, and I type in negative 1.2, 0.4. So notice that unlike the table and unlike Excel, if you use a calculator, at least the TI-83 Plus, to do this calculation, then you include both the left endpoint and the right endpoint. For the table and for Excel, the left endpoint was assumed to be negative infinity. On a calculator, you have to give explicitly the left endpoint and the right endpoint. So I do normal CDF, and I get the answer, which works out to be, again, 0.54035. So that's a little bit about how to use these 3 different techniques, the table, Excel, and the calculator, in order to find areas under the normal curve.